Cool. So Twitter asks, how does the implant system fare against various disturbances from the outside, like electrical, magnetic, Wi-Fi, radio?
Yeah, so the current version of the implant that we have is using Bluetooth low energy radio. So similar to any Bluetooth devices that are out there, they are able to coexist with other devices that are using and sharing our same spectrum in 2.4 gigahertz. Obviously, as you imagine, when you go to concerts or there's just a lot of people, the signal quality does degrade because it is a pretty congested spectrum. So we are actually working on some new versions of the radio that are operating at different frequencies to be able to also send out a lot more data and have it be scalable to millions of electrodes. And then also in terms of sort of electromagnetic compatibility and interferences, obviously it's very important for us to coexist with other systems and just disturbances out there. So there are also well-documented guidelines from FDA that we'll be following and doing a lot of testing for.
So DJ, you talked about outside interference. Can anyone talk about the inside interference? So how to protect the implant from the body?
Sure, I can talk about that. My name is Robin. I'm a mechanical engineer, and I lead the implant mechanical packaging and assembly team. So actually making the devices and designing the seal. So yeah, the body's not a friendly place to be. So what we do is basically create an accelerated test chamber that can mimic the conditions that the devices will see in the body, and basically test the devices at as fast as accelerated rate as we can. At this time, we're limited temperature-wise by some of the electronics components, but basically we can test subsystems to mimic the environment in the body, and by that we've brought some devices in the tester right now to almost a year, and all the implanted ones prior to these implants, we had tested the same architecture in the tester to validate it. And yeah, so there's obviously chemical things attacking the implant. There's pressure. There's mechanical shock and vibration. So all of these things are part of it. And yeah, I think one of the things that really helps is having everything in-sourced in-house. So we have the capability to deposit thin layers of metal. We have the capability to weld glass and machine micron scale with lasers. And yeah, so basically we have all the tools in-house to be able to design any sort of sealing, enclosure, packaging that we need to do.